Hello, Divya. I introduce you a little bit. Našou prvou speakerkou je Divya Mohan, ktorá sa sústredí na posilňovanie komunít a komunitného vzdelávania. Je náčenkyňou zjednodušovania technológií úplne pre každého. Je autorkou publikácií, ako sú Container Solution a The New Stack. Určite si môžete o nej viac pozrieť na vlastne tomto webe, kde ste sa prihlásili. Dnešnou tému si vezme, a to je Webassembly, the next frontier in cloud native. And now I give you, Divya, time. Please take over with your presentation.
Thank you, Lucia, for that wonderful introduction, and I am so happy to be here. So just let me share my screen. All right. Hopefully everyone is able to see my screen today without any glitches. Lucia's introduced me fantastically. I didn't understand much of it, but I could gather something from the words that she made. So I'll just quickly, start off. I'm extremely honored to be presenting to y'all today on this Kubernetes Community Day Czech and Slovak. And as Lucia mentioned, I am a technical writer with SUSE. I am also a CNCF ambassador. And today I'm here to speak about prizes for guessing, cloud native, and its intersection with the WebAssembly ecosystem. Although Lucia has introduced me pretty well, I think because this is the first time I'm actually meeting you guys, I need to be customary and actually introduce myself a little bit better. So the technical writer bit and the CNCF ambassador bit, Lucia's covered pretty well. I'm also the co-chair for documentations, and I'm one of the documentation maintainers for both these projects. I'm also an AWS community builder, which basically means that I get to do a lot of fun community stuff. Space, but also branch out to learning more in the AWS ecosystem. And I'm also an author of the Friday 4 newsletter, via which I keep tabs on the hive mind of the cloud native. What everybody is thinking and what are the latest goings on in the cloud native system. So please do consider subscribing if that's something up your alley. But today is not about me, it's about cloud native ecosystem and its intersection with WebAssembly. But WebAssembly is something not a lot of people have heard about before. So I'm first going to address what on earth WebAssembly is, then look at where we are currently with respect to the ecosystem, how it fits into the cloud native ecosystem, and the actual future for the intersection moving on. So before we start off with WebAssembly or with any technology really, the reason why or how a technology came into being is extremely important to understand, given that what tends to happen is it often fills in for the lack, or it fills in for a problem that is actually existent within the ecosystem. So what problem did WebAssembly solve, and how does it fit into the cloud native ecosystem? So this is a very rough diagram. I'm not very good at drawing. I'm really sorry to all the artists out there who will get offended with this. WebAssembly was in place. And for people who have guessed that WebAssembly is related to the browser, you're partially right at this point. So before this ecosystem, what tended to happen was that JavaScript was like the do-all and be-all of programming languages and compilation targets in that particular ecosystem. What eventually ended up happening was that if you wrote a web application in any, be it Java, be it whatever, it needed to be transcribed to JavaScript via a compiler toolchain. And this was all good because, in the early days of the internet, we all know what the internet looked like. It was composed mainly of static pages, lower levels of interactivity, lower levels of dynamism, and it was working fine. And when we moved to more dynamic nature, a more dynamic nature of the web with higher levels of interactivity, is when there started to be a problem. What happened was that these cons, or these disadvantages of JavaScript started popping up when we brought performance intensive and workload intensive applications to the web. So obviously, because JavaScript was a programming language, there were performance inconsistencies. And by performance inconsistencies, I do not mean that, when you write a hello world application in different programming languages, you'll get different performance every time. That's not what I'm hinting at. I'm talking about, bringing more intensive applications to the web, say like a Google Earth or a Figma or a Photoshop by Adobe. When these were sort of brought to the web app world, what happened was that the performance across systems was noticed to be inconsistent, and that was not all. Is weekly type. To say this to a conference or an audience full of developers and IT enthusiasts, but it was weekly typed, and the whole process of bringing JavaScript to the browser, like the JavaScript browser, in itself was an eventually fast process. Even with the development of great frameworks, even with the integration, with great frameworks like React and so on and so forth. So obviously, given these disadvantages, people had been searching for alternatives since the early 2000s. Now, when we look at how we came from the JavaScript ecosystem to where we are right now in 2022, in the state of WebAssembly, this is how it sort of looks like. Now, I'm very well aware that this graph only shows till 2019, and this is the best graph that I could find, because after 2019, there is a lot that comes in terms of advancements in this space, which we shall talk about in the next couple of slides. But coming back, we are still in early 2000s. We have like only JavaScript as a for the web, and we want alternatives because we are always on the search of alternatives, right, as an industry. So with respect to JavaScript, what came up as alternatives in the very first place were plugins, and we all know how that went down. Flash by Adobe, Silverlight, all those plugins were really mainstream when I was using the internet and I was in school. So and those actually got deprecated or have limited usage on the internet now. But that wasn't the only advancement that took place in the technology space. We were trying to move away from JavaScript. A lot of other stuff came into picture as well. One of them was the release of the Llvm compiler toolchain, which basically was conceived with an idea of bringing more languages to the front end. It was what JavaScript tried to do as well, but it did not fail. I mean, it did not succeed as well as we thought it would. So Llvm was released in around 2003 with the aim of bringing more languages to the front end. Now, as time passed, around 2011, there were two major events that sort of brought us closer to the WebAssembly spec, which was the release or the announcement of the Mscripten project and the Portable Native Client project. Now, both these projects were introduced with the same aim of bringing C and C++ to the front end. but both of them were disjointed efforts. They were started by two separate organizations, and building upon the Emscripten project in 2013 was the ASM.js spec. Now, ASM.js spec, as you probably from the name itself, is a stricter subset, of the JavaScript programming language. What does this mean? So the step pretty much remains the same. Your end goal is still going to be JavaScript, wherein everything compiles to JavaScript. But the ASM.js had a stricter set of rules on what it would allow and not allow. So, for example, it allowed only simple constructs, and it did not allow any of the fancy memory management techniques that JavaScript as a programming language was known for. Now, because all of these efforts, excepting probably the one that I'm going to talk about, were disjointed ones, meaning they were worked upon by really separate people, they did not see as much success. Sure, there was an eventual convergence in terms of the fact that a lot of people arrived at a conclusion very late in the journey. But it was with WebAssembly as a specification that all the major browsers came together and agreed upon something. That is the requirement of a spec that would be a portable compilation target. In 2017, of course, the MVP was, sort of announced. And just recently, last week, I guess, April 19th, the first working draft of version 2, public working draft of version 2 for WebAssembly was announced as well. Now we've talked about how we reached WebAssembly from JavaScript, but we still haven't looked at what WebAssembly is. So abbreviated as W capital and ASM small. This is something that I learned recently as well. It is a binary instruction format, and it borrows from the stack-based virtual machine concept that the native client project had sort of introduced. Now, it is designed to be a compilation target, which means that as opposed to JavaScript, it is a little more efficient, so to say. And it because of the binary instruction format, it is also sort of CPU architectures and can be used on both the client and server applications. So in between 2017 and today, although the show is only up to 2019 currently, what happened was that a lot of specifications aiding the development of the WebAssembly ecosystem came into place. One of them was the specification. A lot of languages introduced support for the WASM language, and in the last year itself, last couple of years, there were a lot of players in the market that came up for building applications on WebAssembly, or using WebAssembly in the clients not client side, in the server side stuff. So it is not just relegated to the browser alone as of today. And with the development of this ecosystem at this crazy pace that we are developing it with right now, one can only foresee the future wherein a lot of your common day-to-day applications are also going to leverage the efficiency and speed of the WebAssembly specification. But we're getting a little too ahead of ourselves at this time, because I yet have to cover how is it different from JavaScript. Because as of right now, with what I've explained, WebAssembly doesn't seem like something that is novel, because it's just replacing that block in that diagram that I showed a couple of slides back, wherein you have, instead of JavaScript, you have WebAssembly. So how is that different? So for that, I've actually come up with another diagram, and it's equally badly drawn as was the previous one. So JavaScript and WebAssembly differ on a lot of counts. This is one of the very first, examples of that. The WebAssembly spec or a code that is compiled to WebAssembly basically doesn't go through a lot of steps, given that the WebAssembly spec itself is in the binary instruction format. The compiled code that you will get at the end of compilation would be binary instruction format. So there's not going to be a lot of fancy memory management stuff like garbage collection, although it is in the proposal for inclusion in subsequent versions. But as of version 1, there are no fancy memory management automations like garbage collection. And given that um, it's the binary instruction format, the actual process of execution for a WebAssembly code is significantly lesser. So that is one obvious advantage over JavaScript. And the second thing is, when I mention binary instruction format, a lot of people who hear that for the first time are like, oh my god, so what about the memory? If the program can actually interact directly with the memory, how do you prevent um, a malicious actor from gaining access to it? So the WebAssembly spec has actually taken care of that as well. Now, in the WebAssembly specification, what has been written down as the structure of a WebAssembly program is that the program is a bunch of modules. Now, what is a module? It's basically an S expression, and it is divided into these various sections, and these sections basically within the program need to be in that specific way. So the first section that you can see in green is the preamble, wherein you actually are going to state that it is a WebAssembly program of version 1. And after that, there will be a bunch of other sections detailing the type, the memory, and it's basically arranged in a particular way. And if it's not arranged in this particular way, it will not allow you to proceed. So one of the benefits here is that the WebAssembly program has only this linear memory allotted this in this memory section per program. So this is declared as a bunch of offsets, and if the program tries to access anything else other than the memory that it's allotted, the module actually tries to access anything else other than the memory it's allotted, it doesn't allow it to. That is like a definition within the spec. So um, so suppose a malicious actor in code, and it's trying to access another module's memory. It will not allow for that to happen. WebAssembly allows for every module to access only its own linear memory, and the module will not have access to the entire process memory, unlike other programming languages. Of course, the modules are able to share memory. I'm not going to say that it's completely impossible, but it requires explicit calls to be made, and the risk of that malicious actor attacking your code and gaining access to your process memory is significantly lower as compared to other programming languages. Now, when I spoke about these different sections, I also mentioned that they had to be arranged in a particular way, right? So, because of that particular sequence, what happens is that the speed and efficiency and the performance, drawbacks that we had with JavaScript sort of, gets conquered, because what happens, and this is something that you don't even have to explicitly do. When you are writing a code into something that can compile to WebAssembly, you do not have to worry about this whole thing, of arranging the sections in a particular way. The compiler will do it for you. So this is not even your headache at this point in time. So this obviously contributes to the speed and efficiency that I spoke about. And with all of this, another advantage that is there at this point in time is that any language that can be currently compiled to the WebAssembly is obviously executable across architectures because of the instruction format. And given the development in the ecosystem, many more languages are actually coming forward with compilers for WebAssembly. And for example, even Python. So these are like some of the advantages and how it differs when it compares to JavaScript. And when we talk about all this, we also need to understand, before we talk about the intersection with the cloud native ecosystem, where the WebAssembly ecosystem is currently. Because till now, what I have said is JavaScript, how is it different from JavaScript? So a lot of you might be thinking, at the start, she basically spoke about, WebAssembly intersecting with cloud native. And there's not one single instance in the past 15 minutes or so where I've actually spoken about anything else except how is it different from JavaScript, and how, how it is basically advantages over JavaScript. So now I'm going to delve into where all WebAssembly is used currently. And this is not an exhaustive list, because every single day, newer applications are coming up in this ecosystem. So if you think that, it's just the front end, it's not just the front end any longer. Everyone's favorite chat server these days, Discord, basically uses WebAssembly modules as well, over and above what is displayed here on the screen right now. If we talk about Photoshop by Adobe, it's one of the biggest adopters of WebAssembly as an enterprise. There's also the Google Earth, Google Meet, Figma. All of these are utilizing WebAssembly. And it's not just the browser anymore, because there are also server-side applications coming up via companies like Suborbital, Fermion, etc., wherein they are enabling you to think about developer productivity and bringing your application to cloud without, compromising on the kind of programming language that you use. So that's a bit about where we are currently with respect to the WebAssembly ecosystem. But when we look at how it intersects with the cloud native ecosystem, the cloud native ecosystem is, as it is, humongous. Right now, if I'm asking you to check out what is there on your screen, you'll not even be able to see half of the cards on it. The reason being, it's just growing at the fastest pace possible. More number of projects come in every month into the sandbox and the incubation categories. And given this meteoric pace, what, where, or how does WASM fit in? With cloud native as a paradigm right now, where we are currently is we do not very much worry about the operating system, or where we are deploying our particular applications. Sure, a lot of us are still doing a mix of cloud native and traditional on-prem. I'm not going to say that we've completely switched to cloud native, but when we speak about the traditional premise of having your own data center, knowing which OS and which computer or which server and what libraries and what specific programming languages we're using, we have come a long way from that tightly coupled architecture. And with the current premise of cloud native, we are looking at distributed applications. And where WebAssembly fits into the cloud native paradigm is that it offers that additional layer of abstraction. So if you see in this particular diagram, what cloud native is currently doing, I mean, not currently doing, what it has been doing is that we just have to worry about the application specific libraries and the actual app that we write. With WebAssembly, what tends to happen is that since we just are going to have a binary instruction format to which our actual you know application compiles to, this could virtually be run anywhere. And by anywhere, I literally do mean run it anywhere. You could have it run on the edge, you could have it run inside a k8 container, you could have it run on a browser, you could have it run on devices such as Raspberry Pi. You could have it run inside an application which is on your traditional VM. You could literally have it run anywhere because of its format. And we are with WebAssembly moving towards a declarative form of architecting our applications. And finally, the whole purpose of this presentation, wherein we have what are all these WebAssembly applications and what is WebAssembly, it brings us to this: which are the cloud native projects currently using or supporting WASM? This is again not an exhaustive list, because cloud native projects using or supporting WASM are pretty it's like keeping track of an ever expanding landscape. So I can speak personally for stuff that I'm involved in. One of them is KubeWarden, which is something that I work on at documenting in SUSE, wherein we use WebAssembly modules to basically allow for dynamic admission control in Kubernetes. So why at this point are we using WebAssembly? It's because of its binary instruction format. The speed is actually at this point not as important as the fact that the policies that we write for dynamic admission control can be written in any programming language that can compile to WebAssembly. So for policy writing, you basically do not need to relearn a new language. Uh, there are very few languages supported today. I'm not going to say that we've introduced support for every conceivable language in the ecosystem, but as and when the ecosystem of WebAssembly develops is when we will see a subsequent development in these projects. For example, even in one of the projects that is not really cloud native, but it's more of in interfacing with developer productivity, the suborbital projects, they are open source, and they basically deal with a whole server side environment wherein we actually have an environment very akin to Node.js for WebAssembly. And when we speak about the other projects that are listed here itself, like Trustlet, which is a Rust implementation of Kubernetes, or Wasmer and Wasm Edge runtime, which are runtimes for WebAssembly, you can see that it's a fledgling ecosystem, but it is set to grow. Given that the interest around the diversity of architectures that WebAssembly supports or is can potentially set to support in the future is pretty amazing at this point. So Solomon Hykes, who is the founder of Docker and the creator. So he mentioned that how important WebAssembly would have been had it been in 2008 can be sort of attributed to the fact that if WebAssembly, along with the WASI specification, which is specification for network interface modules, if that had existed in 2008, they wouldn't have had to create Docker, because Docker, what it essentially does is provide that level between your operating system and your application. So Docker does that with the help of containerization. So with WASM and WASI, we eliminate that last layer of abstraction that, like I talked about in the previous, in one of the previous slides. It basically eliminates that last level of abstraction and creates a standardized system interface, which was the missing link. And this tweet is still there on Twitter if you want to go check it out. And it was on the announcement of WASI that basically Solomon Heights said this. Now, where are we headed? Because one of the things that we want to look at when we are talking about a technology is that, does it have any future? Um, sure, with WebAssembly, it does look like it's going to potentially replace JavaScript. So let me first debunk that myth and say that it's sort of not true, because if you come to the front end aspect of it, it's not going to replace JavaScript. Even today, with the version 2 of the specification out, a lot of it is integrating with JavaScript to provide that better user experience. So it's not replacing JavaScript, and JavaScript is not, unfortunately, going anywhere for those who are hoping that. But that aside, what what is the future of cloud native? So Gartner, which is one of the leading analyst publications in the IT industry, it has postulated that by 2025, which is just like 3 years ahead, cloud native platforms will be serving as the foundation for more than 25% of, not 25, sorry, 95% of the new digital initiatives. And this is a stark contrast to the 40% that was, hypothesized by Gartner back for 2020. So if you look at that meteoric rise, you can already imagine the kind of, um, you can already visualize how the landscape is going to look. It's going to have way more many tools. It's going to have way more many certified providers, and it definitely is going to have WebAssembly as a part of it. It already has it as of today. So when we are speaking of cloud native being a foundation for 95% of the new digital initiatives, we're also speaking about distributed applications being on diverse architectures. Currently, we have achieved the fact that we can sort of break down our monoliths into distributed applications, containerize them, and sort of have them as microservices across operating systems that we currently know. But what about those that we haven't tapped yet, like running applications and bringing compute and edge closer together? It's one of the major goals, right, to avoid latencies and to avoid to provide customer satisfaction. It's one of the goals to bring compute closer to edge. And with that, obviously the number of CPU architectures that we sort of support are going to diversify. And WebAssembly, given its binary instruction format, is a perfect candidate to fit into this requirement. And that is where I actually see WebAssembly going. Given that we already have a lot of these initiatives underway. We are yet set to grow in that direction. And when I'm speaking about WebAssembly and thinking about it in the future, what I also know for sure is that we will be reimagining a lot of the stuff that we currently know. Like, remember how we actually rethought our whole observability stack when containerization came in 2008? Before 2008, if anybody were to tell you that we would have distributed logging and tracing systems, or if anybody were to tell you we would have stuff like chaos engineering in place, would you have believed them? Because I sure would have not, given that um, I was in college at that point in time. The second thing is what I was introduced to when I entered the industry in 2012 was just plain logging and chasing, no fancy frills, nothing great in terms of visualization tools, just the basic Splunk and Wiley and APM infrastructure. But when containerization came in, it reimagined the whole way we look at observability, and the kind of stuff we have right now. I don't think we could have imagined that back when we did not have containerization. Similarly with security. Security is everyone's favorite buzzword these days, especially supply chain security. And it should be, given that the number of attack vectors, given the number of malicious actors in this space. Reimagining security when it comes to WebAssembly is going to be equally important, because there will forever be newer attack vectors coming up, even though WebAssembly is relatively secure as of now. But with technological progression and with advancements, it's not like hackers are reading 1990s books. They are going to keep themselves updated, and there are always going to be newer attack vectors. So reimagining security paradigms is going to be another I think direction in which WebAssembly will branch out. And of course, like I said before, edge and IoT are another set of buzzwords that have been floating around since a lot of time. We finally might actually be able to bring the edge and compute closer for specifically IoT use cases, given that there is an increasing requirement. Sorry, there's an increasing requirement for a language or a specification, or even like that standardized system interface to um, do the do that bridging of the gap, if I can say, put it in the most crude way. And I've mentioned databases here, and there's already a lot of work underway in this for implementing UDFs in the WebAssembly context. A quick Google search can literally give you 3-4 pages of valuable information, and I don't think I want to go too much into depth, but adding that extra level of isolation and security when it comes to the humongous amount of data that we produce. I think web is another interesting direction where I see WebAssembly sort of branching out is the database side of things as well. Last but not the least, I think this was one of the last slides that I made, because the version 2 working draft, public working draft, was just introduced last week. And this doesn't mean anything, to be honest, because it's not like version 2 has been released officially. It's just the public version draft, public working draft, and it's subject to amendments, modifications, or even accents. But the hope is that with the branching of WebAssembly into cloud native and into areas other than cloud native as well, we are looking at more more applications that can run on diverse architectures, and that help developers focus on the actual coding and development aspect, rather than reimagining their applications for different environments. And with that, I think I want to open up the floor for any questions that you might have. And before that, I would like to really thank the organizers, as well as all the lovely audience that's attending today, for their time and patience. Thank you so much, and have a fantastic day ahead.